Welcome. This is the paper we're going to do is January 2021. Of course, Unit 1 Chemistry for Pearson Edexcel International A level. I'm going to use some highlights as I go through this paper. So let's see here. So the first question here, I will just go direct to the first question. The first question says, which of these compounds has the same empirical formula or some empirical and molecular formula? So they have to be the same. Remember that empirical formula is the smallest whole number ratio, and then the molecular formula can be anything. So we have to look among all these things, something that cannot be further divided, because if it's a molecular formula, it means it cannot be made smaller any further. However, there is a problem with A because, as we see, A can be converted into CH2. We can see here C can be converted into C2. When you divide 4 by 2, of course, you get a 2 and the other side 5. Here, this one can be divided further into CH2. So all these three are wrong. The only correct answer is a B. Therefore, answer comes out as B, of course. So the next part, let's look at question number 2, which says 6.02 10 to the power 23 atoms in 0.2 mole. We want to know, because they say there are 6.02 10 to the power 23 atoms in 0.25 moles of, we want to find among all these three, which one has this number of atoms when the number of moles are that. As you know previously, to find the number of particles, in this case, these are the number of particles. These are particles. To find the number of particles, we have to multiply the number of moles times, of course, the specific atoms. In this case, they are atoms, so specific atoms present in that compound, molecule, or element, times Avogadro's number. Now, on the other side, the answer we get is these atoms. This is similar to Avogadro's number here. So to make the right and left side similar, it means this value here has to be equal to 0. To make that 0, it means we're going to do to 0.25 times a certain value gives us 1, and therefore x should equal to 4. So the atoms that specific compound has to have should be 4, and if we can see, it's only C that has 4 atoms in it. The others, like helium, has 1 atom. This is 3 atoms, and this is 5 atoms. So the right answer should be basically a C. When we go to question number 3, it says, which aqueous solution has the highest concentration in moles per decimeter cubed of chloride ions? Now we have to know carefully. In here we have one mole of chloride ions. Here we have 1 mole of chloride ions, and here we have 1 mole of chloride ions. However, here we have 2 moles of chloride ions. Okay, so we have to make sure to convert concentration from gram per decimeter cubed into mole per decimeter cubed. We divide by the number of moles. So, okay, so here we're gonna see. Oh, sorry, we divide by molar mass, not number of moles, molar mass. So to divide by molar mass, we're gonna, of course, say 0.1 gram or 0.1 divided by, in this case, if you add that, it will be 36.5, so which gives us 2.739 times 10 to the power negative 3. And this one here gives us, as you can see, as you go down, these values are going to be bigger, so the smallest, because here we are looking for, they say, the highest. Since these are times 10 to the power negative 3, of course, this is going to be the highest, because as the values, of course, become smaller and the powers are into negative, that is going to give us the highest concentration in mole per decimeter cube. This concentration here is lower than that concentration. So in this case, we can see A should be the right answer. If we go to question 4, which conversion has the lowest percentage atom economy? Remember, percentage atom economy is going to be the molar mass of the desired product divided by the molar mass of either or products or reactants times 100. In this case, we can see if they said the lowest percentage atom economy, even before you calculate, you have to know it means A is wrong, because A is going to have all the reactants end up as a product, so it's almost 100% atom economy. And here, you have to look at the number of moles that, the molar mass that ends up in the non-desired product. Here, it's only 2 that ends up in the non-desired product. Here is just a few of this, but here, look at this. Even without calculation here, we can see there is a lot that ends up in sodium carbonate, which is an undesired product, and less in calcium carbonate. So automatically the answer comes out as Z. And again, to affirm that they asked for the lowest percentage atomic economy by mass. It means the desired product has less than what ends up in the non-desired product. And the correct answer here should be basically a B. So question 5 says, which of these atoms has the most neutrons? Of course, to find the number of neutrons, we're going to say now molar mass minus, of course, the number of protons in this case. So here 115 minus 49, here 124 minus 50, 123 minus 51, 124 minus 52. Here, if we're looking at the one that has the most, it means this one here. Automatically, you can see it's a 124 minus 50. These values are all lower than 124. This 124 is minus 52, so it cannot be the same value. So this one here will have the most neutrons. The answer is basically neutrons. The answer is going to be a B. So the next question says, a p block element in period 3 of the periodic table reacts to form an ionic compound. Remember, they said period 3 and it's p block, which could be the electronic configuration of the ion formed by this element. It's a p block, meaning the outer electrons should be in the p. However, if it reacts to form an ionic compound, so here they say which could be the electronic configuration of the ion formed. The ion formed when p block elements react, they actually, of course, we have the metals like aluminium, but most non-metals are going to be, in period 3, are going to be gaining electrons, basically. Again, this question is asking, which could? This cannot be. If this one is a P, this wasn't a P, because if it reacted to form an ion, the last electron is still S. That is wrong. Remember, when they react, they form the nearest the configuration of the nearest one. So the only correct answer should be this, because it forms a stable outermost shell, and as we know, it's because the first one was in period 3, so here we can see the correct answer here is going to be basically a B. All the others do not make sense. Question 7 says the period 2 element with the highest melting temperature is, this is period 2. Highest melting temperature, this is not in period 2. Now, highest melting temperature, of course, you guys know periodic trend. When you look at melting temperature, it increases like that and then like that. So basically, this is going to be the maybe group 1, group 2 for period 2, group 3, or around here, group 3. Let me just do an erasing here. So if it's going to be like that, 1, 2, 3, and that is where carbon comes in. This is going to be for where we have carbon, and then further it goes down. But here we can see, because the first 3, like 1, 2, 3, these are metals, so it's basically metallic bonding. But for C, carbon, that is where we have, in this case, we have the covalent bonding, and it's a giant structure, so it's going to have a very high melting point, as well as a boiling point. So the answer here should be only C, which is carbon. Silicon is also not in period 2. Question 8 says, which of these has the greatest electrical conductivity? Electrical conductivity, let us see. This is a simple molecule. This is liquid at, let me say, it's going to be liquid at room temperature. So meaning greatest electrical conductivity, liquid mercury. So this is an ionic bond. Ionic compounds in solid state do not conduct electricity. This is, let me see which one else. If they're asking for greatest electrical conductivity, we are looking for a liquid metal. Water conducts electricity, but it is not going to have the greatest. Liquid mercury is going to have the greatest electrical conductivity. So which of these ions has the greatest ionic radius? To look for the greatest ionic radius, it means if the radius is really big, it means the number of protons are fewer. So fewer protons, that is 1. And then, of course, more shells. Because we are looking for greatest ionic radius, fewer protons, more shells. Or even more repulsion. More repulsion or more screening effect. Okay, so let's see. We have fluorine. Fluorine has sodium. Sodium has more protons than that. But when sodium becomes sodium plus, actually all these have the same number of shells. If you can look at it, all these have the same. They have the same number of shells with occupied electrons. It means they're all going to have the same electronic configuration. Now, the one with the highest number of protons is going to have the smallest ionic radius. So we see all these are going to have 10 electrons, 10 electrons, 10 electrons, 10 electrons. occupying their shells. So here we see number of protons. Aluminium has the highest protons, then we have sodium, then fluorine. This has fewer protons, and since they have the same occupied shells, it's going to have the greatest ionic radius. So the answer is basically A. Question 10 says, which of these ions has the greatest polarizing power? To have the greatest polarizing power, there should be, the cation should be the smallest, and it should have the highest charge. Of course, as we can see, calcium is smaller than all these. These ones are all basically in the same period, but as we know, actually, because I don't want to say they're all in the same period, but if we consider after gaining or losing electrons, they all have the same, they're isoelectronic basically. Again, I want to correct that, they're isoelectronic. So if they are isoelectronic, it means they have the same numbers of occupied shells, yet this one has a higher number of protons. Another thing also, this one has a higher charge. Calcium 2 plus has a higher charge, and it's going to be the smallest among the three due to the presence of more protons. Therefore, it's going to have the greatest ionizing power in comparison to the others. Question 11 says, which of these does not have a structure formed by a giant lattice of carbon atoms? Of course, this is a simple molecule. Graphite is giant, graphene is giant, diamond is giant. This is the only one which is not giant. Fluorine is a simple molecule, so the answer basically should be A. This is really easy. Question 12 says, which of these molecules is the most polar? To be most polar, it means you should have the greatest intermolecular, actually the greatest charge difference or greatest polarity. We all know that fluorine has the highest electronegativity, so it means if we have hydrogen fluoride, hydrogen, remember the others are all hydrogen having less electronegativity while fluorine having the greatest electronegativity. The difference is going to be very great in hydrogen and fluorine. If we consider the example we have here, fluorine, oxygen, fluorine, here we can see the difference in electronegativity is not going to be that great. Or I could say here polarities do cancel out, or you would say that it is kind of symmetrical. This is symmetrical. This is not symmetrical. This is going to be nonpolar because it's actually symmetrical, or the dipoles cancel out. And this one here, nonpolar, because the dipoles are going to be canceling out, or they're going to be, basically, it's non-symmetrical. It's symmetrical. The only one that is non-symmetrical is going to be A, and therefore molecules in most polarity within the molecule is going to be in HF, because most of the others, dipoles are going to cancel out, or they're going to be kind of weakened. 13, a substance is labeled with a hazard symbol that. Okay, easy. This, of course, everybody knows. This is corrosive because you can see something poured onto some other substance and then it's kind of eating it away. That is corrosive. Really, really easy. Okay, what is the IUPAC name of this alkane? When we are naming alkanes, we have to look for the longest carbon chain. Let's see if this is carbon. I always like to put the carbon so that I can see which one has the greatest number of carbons. So I'm going to cancel that out and leave that to be the longest chain. Now, if I have the longest chain, I have to ensure that I know which I label the carbons from left to right. If this is carbon 1, if labeling from left to right, this could be basically, let's see, carbon 1, 2, 3, 4, 5, 6, 7, 8. Or I could label from the other side, which is carbon 1, 2, 3, 4, 5, 6, 7, and 8. So here we can see. Okay. From left to right, I have a side chain on carbon 3, a side chain on carbon 5, and a side chain on carbon 6. Then from right to left, I have a side chain on carbon 3, on carbon 4, and on carbon 6. 3, 4, 6, 3, 5, 6. This is going to give me a smaller value. So it means I'm going to label from right to left. So from right to left, I have methyl groups on carbon 3, a methyl on carbon 3, a methyl on carbon 4, and a methyl on carbon 6. So I'm going to say 3, 4, 6. Since there are 3, trimethyl. And then I have to add the longest chain since it ends in 8 carbon, so I say octane. you have to be able to add them properly before you name it. So the answer here comes out as 346 trimethyloctane, which is a C. We go to question 15. It says petrol and bioethanol and hydrogen are fuels. All three of these fuels, number one, burn to produce greenhouse gases. I see. Of course, they're going to produce carbon dioxide, because if they say they are all they are all fuels, these two are going to produce carbon dioxide. Now, hydrogen as a fuel, it will produce water, because hydrogen burned in oxygen is going to produce kind of water vapor as a gas. That is a greenhouse gas. Water vapor is a greenhouse gas. Are overall carbon neutral? Nope. Are overall sustainable? Not. Petroleum is not sustainable. They biodegrade rapidly. Nope. Rapid biodegradation is not going to be that. So the answer here comes out to be A. Of course, they produce greenhouse gases. Question 16 says cyclopentane undergoes free radical substitutions with bromine. Substitution reaction with bromine. Okay, cyclopentane with bromine. Which of these is the overall equation for this reaction? Overall, if you have cyclopentane, if it's cyclopentane, let me use this as an example. E of carbon, of course, carbon 5, hydrogen 10. Undergoes radical substitution with bromine. Okay, Br2. The end, it's gonna give us C5H. If one bromine is gonna come, so it's gonna be H9 Br. The other bromine reacts with one of the hydrogens that has come up to produce that. So this is gonna be, the answer is D. As you can see, this is the overall equation for the reaction, not the mechanisms leading to the formation of the product. No. So the answer here should be D. So question B says, which statement is not correct about the reaction system? Let us see. Only the initiation step involves homolytic bond fusion. Actually, most students thought that only the initiation step, this part is right, but actually it's wrong. When I did this with some of my students, they thought this answer was right, only the initiation. No. If you look at this is an example of a propagation step, but actually it involves homolytic fusion, because this goes like that, and that comes to this, and these two fuse together, forming of course in the propagation step. So this is forming a product from the propagation step, but this is also involved, this part here involves homolytic bond fusion. So this one is supposed to be wrong, and in this case it becomes the right answer. As you can see, only some bromine is converted into free radical. Nope. Propagation forms more products than termination. No. And further substitution reactions are likely to occur. That is correct. So the only not correct answer should be an A. Next question says, which free radical is likely to form in a propagation step in this reaction system? Which free radical is least likely to form? Hi, come on. This one here will not, it's very, very unlikely that it will form during this propagation, during the reaction, basically, because no way. So that is actually, it's easy to predict that this is the answer. Then question D says, which alkane could be formed in a termination step in this reaction system? Termination step, remember, in termination for this case we'll have, let me see, we can have carbon 5. Initially it was a carbon 5 hydrogen 9. So we can have a carbon 5 hydrogen 9 radical combining with a carbon 5 hydrogen 9 radical, or we can have a carbon 5 hydrogen 9 radical combining with a Br radical, or a Br radical combining with a Br radical. I'm just using the simplest termination reactions that can occur, although there are going to be other propagation products that could react to form other termination products. So here they say, which could be formed in a termination step in this reaction. Remember, they have said which alkane. This, not alkane. It's a hydrogen, it's a halogenoalkane. This, not alkane. The product formed is not an alkane. This is the only product that is going to be an alkane. So it's going to be carbon 10, hydrogen 18, which is basically, if it's carbon 10, hydrogen 18, it's going to be that combining with the other side to produce them. So the answer here is going to be C, as you can see. So this is the only alkane. Be very clear, read the questions carefully. The others will be halogenoalkanes or just bromine. So that is the answer. And the last part of this multiple choice video says, which of these is not a way of limiting global problems caused by polymer disposal? A says developing biodegradable polymers. Remember, the question is about which of these is not a way of limiting global problems. Developing biodegradable polymers is a way of limiting. Exporting polymer waste. No way. Exporting polymer waste to other countries is still, you're giving them waste. There is no way it could help in one country, but it's creating more pollution in another country. So this is way wrong. It's not correct. So this brings us to the end of this multiple choice video. Thank you so much for your time, and I hope to see you when we discuss section B.